So welcome everyone. My name is Ihor Dvoretsky. I'm a developer advocate at Cloud Native Computing Foundation. And today we'll speak with you about how to run Kubernetes locally with Docker for Mac and Docker for Windows. Today we have two presenters from Docker. Both are representing this company and both are working on these projects. We have Guillaume Tardif and Guillaume Rose. So please go ahead with Docker for Mac and Docker for Windows presentation.
Okay, hi. So I'm Guillaume Tardif. I work at the Docker office in Paris and work on Docker for Mac and Windows.
Same, I'm Guillaume Rose and I'm working on Docker for Mac and Docker for Windows for a year now.
So today we're going to talk about the Kubernetes integration in Docker for Mac and Windows. I will just quickly present the Docker for Mac and Windows tool first, and then we'll dive into Kubernetes. So just, well, as a reminder, Docker for Mac and Windows, it's a native application that you can run on Mac or on Windows, and that's the easiest way to get started with Docker on those platforms. So Docker runs on Linux machines, and for Mac and Windows, we run this inside a Linux VM, and this is packaged completely inside Docker for Mac or Docker for Windows, so you don't need to install VirtualBox or install any other specific VM or configure it. It's all packaged as part of the Docker for Mac or Windows application. We also take care of the network and file sharing, which means we try to make this as transparent as possible so that people get the impression that everything is running locally on the host, and you don't need to know the IP address of your virtual machine or to specifically configure the file sharing between your host and the VM. There are some configuration options, but most of it works straight out of the box. And with Docker for Mac and Windows, you get you get a slight whale menu here at the top of your menu bar, and something similar on Mac and Windows with a UI to configure a few preferences. You get auto updates, so you get notifications when a new version is available. And you can install either an Edge version or stable version. On the Edge version, you get notifications for a new version every month, and maybe some RC versions in between. And on the stable versions, you get notifications for new versions every 3 months. And we've just reached about 1 million users beginning of 2018. So both products were started in 2016. We've got roughly 700,000 users on Mac and 300,000 users on Windows. The two products are now built with a Linux Kit virtual machine. We'll dive into this in a minute. So basically, this is also a Docker development Linux Kit, which allows to build virtual machine images with services that you describe quite nicely. And on the host, we also run some tools to make the networking and the file sharing transparent, so that we share some things between the hosts and the VM. So for the networking part, we've got a VPN kit process that runs on the host. And basically what it does is that if you try to expose port, for example, by running docker run -p 80:80, so you start a web service and you try to export the post. You try to expose the port 80. By default, it will expose the port 80 inside the Linux VM, and VPN kit is registering to receive notifications of when you expose ports, and it will expose the port on the host as well. And when the port is exposed, it will also get all the low-level network events and reproduce them on the host, so that we've got something completely transparent between the host and the VM. And for the file sharing on Windows, we rely on Samba to mount Samba drives between the host and the VM. And on Mac, we have also an internal development, OS 10FS, which works a bit similarly to VPN Kit, so it listens to low-level file system events and reproduce the events on the VM if it's events coming from the host or vice versa. And regarding Linux Kit, so it's an internal development. Well, it's open source, but it's developed by Docker. And this project is to easily describe a VM and build VM images from YAML files. So here we've got an example where we've got the base of the virtual machine here, so from which kernel we start. The virtual machine will include some description of the basic file system, including containerd binaries. And then when the virtual machine boots, it will include several services that are running on top of containerd. Some of them are executed just on boot, and some of them will just continually run inside the VM. So here we've got an example of a virtual machine including just a Redis binary, a Redis database that is started when you start the virtual machine. And you just need to describe with this YAML file the services that you want to run inside your virtual machine. So that's the base of our VM for the Docker for Mac and Docker for Windows product. And so the file system on the VM is immutable, and then all the services are run inside a container, inside containerd. So your on boot and services here are basically Docker images running in a container. And so to summarize a bit the architecture of Docker for Mac and Windows, we've got something quite similar, where on the host we've got the hypervisor, which is either based on the Apple hypervisor framework on Mac or Hyper-V on Windows. And then we've got some components for the file system sharing, so that's either Samba or OSXFS for the file system, and the VPN kit that we've mentioned for the network part. And on top of that, we've got Linux Kit VM, which runs containerd, and then services, including the Docker engine, running on top of containerd. And coming back to the host, on the host, we've got the Docker command line, the CLI, we refer to this as a CLI, Docker command line that runs on the host and that can connect to the Docker engine to build or run containers. So that's for Docker for Mac and Windows. And then we first announced the Kubernetes integration at DockerCon Europe last year. And it was first introduced in a release of Docker for Mac in December last year, and then a couple of months later on Docker for Windows. And the idea here is to have something really transparent as well for the user, so that they can just, with the one click, install a Kubernetes cluster with so it's a single node cluster with a master also executing services. And the users don't have to configure anything, it's just a one-click install. Then the user can play with Kubernetes and use the kubectl command lines. So we'll dive into this in a second. And we just released today the version of Docker Enterprise 2.0 that includes the Kubernetes integration as well. So these versions pass the Kubernetes conformance tests. And currently on Docker for Mac and Docker for Windows, we're running with Kubernetes 1.9.6. So we've already run a couple of upgrades. And the first versions were running Kubernetes 1.8.2 in December with Docker for Mac. And then we upgraded to Kubernetes 1.9.2 and then recently 1.9.6. And to come back to our architecture diagram, we've got a couple more boxes with Kubernetes. So we still have the same base with the hypervisor running on the host, with still VPN kit for the networking parts, and OSXFS or Samba for the file sharing parts. The same Linux Kit VM with containerd. And then on top of containerd, we've got a few more things than previously. So we still have the Docker engine, and we've got a kubelet binary running inside the VM. And on top of kubelet, we've got the Kubernetes services that will run with with kubelet and the Docker engine. And we can either run a Swarm cluster or a Kubernetes cluster. So both things are still available. We'll describe this compose service box a bit later in the presentation. And when user activates Kubernetes, they will have, in addition to the Docker command line, they will also have available on the host the Kubernetes command line. So they will be able to run kubectl or whatever, the usual kubectl command lines. So that's what has been added on top of the existing Docker for Mac in Windows application. So the user interface is really simple. You've got one checkbox that's disabled by default. So when you install Docker for Mac or Docker for Windows, Kubernetes is not enabled. And you can just switch to the kube pane, click on Enable Kubernetes, and then this will install a full-fledged Kubernetes cluster without changing any configuration or anything by default. So there are a couple of, well, more than a couple, but a few Kubernetes services that run inside Docker containers. By default, they are all hidden. You can display them with checking this checkbox here. It's more for debugging purpose, but it's not really useful for just deploying standard applications. Is that it?
Yes.
I can give you the...
Yes, so we've seen that the VM is built with Linux Kit. So inside Linux Kit, we have included a service that contains Dockerd, kubelet, and we use kubeadm to bootstrap the cluster. So, and in order to drive everything, we use a small Golang server to drive everything so that from the host, the VM will be, the Docker application will be able to pilot the VM and say, hey, start Kubernetes, stop it, reset, etc. So we have this mechanism to control it, and also we use a configuration ISO to start the VM and give to the VM the necessary bits to start up, like Kubernetes certificates and the Kubernetes expected version for upgrade, but other stuff. So let me show you, for instance. So I can go inside my VM and see all the service running using the container CLI. So with this simple command, I will go in the VM and list all the services run on top of containerd. So I can see that I'm running the famous Docker C plus Docker plus kubelet service, but also everything needed to do a diagnose if something is wrong. I have also everything for the time synchronization with NTPD and some bits for the networking. I can also show you what's run in the VM with a simple PS3. Oh, sorry. It's really better with a larger screen. So as you can see, we have the init process, then containerd, and in this running in containerd, the 7 services, and inside the little bit big service, which is Docker, Docker with kubelet, Dockerd with kubelet, all the Kubernetes services, etcd, the kube API server, but also some services required for NFS and for volume sharing. Also, I've talked about configuration ISO. So this ISO is described as a JSON file, which is unpacked as a regular file, but it contains this kind of entries: the swap size, the network configuration, the proxy configuration, and if you know kubeadm, all the certificates required by Kubernetes.
So this ISO is used to boot the VM, basically.
Yes. So what's happened when I click Enable Kubernetes? So the first thing we do is install kubectl in the path on the host. Then in the VM, we run kubeadm init. We then start kubelet, and when then we wait for kubeadm to finish. Once it's finished, we try to see if an upgrade is needed. So if it's needed, we run kubeadm upgrade. Then after that, we update the kubeconfig on the host. Thereafter, we open the port for the API server on the host to the VM so that I can run kubectl, get hold, etc. And at last, we start custom controllers for special needs, like for persistent volume claims, load balance service. And at the end, we install Compose for Kubernetes so that we'll be able to do Docker stack deploy on top of Kubernetes.
So we'll come back to the last Compose part at the end of the presentation.
Yes. So talking about upgrades, so Docker for Mac and Windows try to make Kubernetes upgrade as transparent as possible. Currently, the Kubernetes version is tightly linked to Docker for Mac and the Windows version, so you cannot choose which version of Kubernetes you want to run. And yes, as I said before, when we start the application, the current version and the expected version are different. We run kubeadm upgrade. So talking about Kubernetes feature, one of the most used feature is persistent volume. So as Docker for Mac run in the VM, we have a Linux VM, we have host path volume. So we can mount a volume inside the VM, but also a volume located on the host. So this is done with OS X NFS and with Samba Windows. So this system allows us to have to develop on Kubernetes with Docker for Mac and Windows. On Mac, because we use OS X FS, we have the support of iNotify. So if you change a file on your host, the event is replicated on inside the VM in the pod. So we also try to include as many tools as the developer needs. For example, NFS, Git, Ceph, and RBD volumes can also be mounted in Docker for Mac and Windows. So when you use Elm or this kind of tools, you need to have persistent volume claims. So persistent, when you install Docker for Mac and Windows, we give you a persistent volume claim controller. So for instance, if you create a persistent volume claim, automatically a controller will go behind the scene, create a persistent volume, which use a host path. And this data is mounted directly in your home in .docker/volume. So if you want to use a stateful set, since we have this controller, it works. Talking about network, so there, for the network part, we use a simple CNI bridge. You don't have to choose between Wave, Calico, etc. It's just a simple bridge. It works. And for ports, so if you want to reach your service from the host on the VM, you can do it by just setting a load balancer port, a service, or not port service. It will be automatically exposed on the host with VPN kit. We just wrote a controller for that. So let's do a quick demo of this.
Okay. So we're trying to, so currently we're running Docker for Mac, and if I go to the UI, it's already enabled. We've already enabled Kubernetes. And just when you enable Kubernetes, it actually downloads a few kube images, and it might take a couple of minutes. So we've done this before. So what I'm going to do is try to install a Kubernetes application. I'm going to init Helm first, and then I can install a Redis chart. Okay, so that's all running. It's created the pod, and I can do a kubectl get all. I've got my Redis pod and deployment and everything running. I can also check. I've got one container running Redis, so it's seen as a Docker container. And if I want to come back to the status of my application, yeah, sorry. Okay, so it's all running and I can start using it if I want. I can, so I'm just going to follow the help part here to connect to my, yeah. Sorry. So I'm just going to connect to the Redis application. Currently, the port is not exposed, so I'm going to use this command to go inside the kube cluster. Sorry. Okay, and now I can run the Redis client. So I'm running this Redis client from inside the kube cluster. And I'm logging into my database. I can do a set full bar, save. Here we go. So that's all fine. Redis is working okay. And so I go outside of the cluster. I can check if, well, there was a persistent volume claim created with the Redis install as well. So I can look at this. So I've got persistent volume claim that was created with the Redis chart, and the persistent volume controller automatically created a persistent volume. I can look at it if I do. Okay, so this gives me the details of my persistent volume. I can see here that I've got this path where the volume has been mounted. And if I look at the content of the persistent volume, I've got my Redis folder with the config and the data that's been created. So it's all available on the host and it's shared transparently with the VM. So currently I've done all of this by connecting inside the kube cluster to get access to my Redis database. I can try to expose this port on the host so that I can run the Redis client from the host. So if I look at the kube service at the moment, I've got my Redis service. It's exposed as a cluster IP type. I can change this to a load balancer type. So I'll just run the upgrade command to set the service type to load balancer. That's done. And if I check my service again, now it's load balanced. So it's exposed on the 6379 port on the host. And I can run Redis client from the host, still with the same authentication, and get full, and it should get me the same data that I've already set in the database. So with this, we've got a full application deployed with Kubernetes, and we can access it from the cluster or from the host directly. And we can switch back to the presentation. Okay, so so far we've used only the kubectl commands, except just for checking if the container was running with a Docker PS, but I deployed everything with kubectl. And we thought it would be nice to be able to use the existing compose files and to be able to deploy compose files on a kube cluster as well as deploy it as before on a Swarm cluster. So this is why we added this mysterious compose service that we mentioned a couple of times before. And basically what we've done is that we use the API Kubernetes extension to provide a new Kubernetes type. So we provide a new type called stack, and we've got some controller to receive deploy commands for this specific type, and to be able to interpret this and to read Docker Compose files and deploy the corresponding containers in the kube cluster. So with this new type stack, you can do a kubectl get stacks, and to list the stacks that have been deployed, exactly as if you do a Docker stack ls. It will also access the kube cluster and list the stacks that have been deployed. And inside your Docker Compose file, you can specify volumes, or you can specify ports that are exposed and things like that. And we automatically create the persistent volume for the Compose volume described in the Compose files. And we automatically also export service as type load balancer when the port is exposed to the host. And from on the command line side, when we've added some option in the Docker command line, so that you can, by default, when you use Docker Stack, it will talk to a Swarm cluster. But if you change the orchestrator option to Kubernetes, it will be able to talk to a kube cluster and run the same commands. So deploy, remove, list services, etc. Will work on a kube cluster as well as on a Swarm cluster. So this is an option that is specified in config.json, and we can also override it with an environment variable if we want to switch back to Swarm or to Kubernetes without changing the config.json file. Guillaume, do you want to
yes.
give us a show of that?
Oh, sorry.
Control L.
So, sorry, Control L. Oh, Control L. So here is my configuration. I've already enabled Kubernetes. So you can see this in my docker/config. I have my default orchestrator is Kubernetes, but I can still use the Docker Swarm. So let's run export Docker orchestrator equals Swarm. Let me show you my Docker Compose file. So it's a simple Compose file with front-end web, with a backend words, with 5 replicas, and the database which run Postgres.
So the backend is just a REST services implemented in Java.
Yes. So let's do a Docker stack deploy. Oh, my Swarm is not initiated. So let's just init it. Okay, I can deploy it now. So let's see what is running. So I have five containers. Oh, sorry, 3 words and 1 dispatcher. Okay, that's fine. So let's open the application. All right. So the more I had a backend, the more the students are random. So, okay, my service is deployed on Swarm, but I can also deploy it on Kubernetes. So let's remove it. Okay. Oops.
Docker stack there.
Okay, so only my Redis is left. Let's keep my default configuration. Let's unset Docker orchestrator. Now I can run a Docker, stack deploy, but this time it will be on Kubernetes.
So it's exactly the same compose file that we deploy on Kubernetes and on Swarm. No change at all.
So we can look at the services. We have 1 deployment per service. So there is the DB, web, and words with 5 replicas, so that I have 5 pod words with 1 DB and 1 web. And the Compose controller has created everything needed for this application to work. So we have deployment and services. So I've exposed my web on the port 80, so a service has been created according to that. So I can see it deployed same as before, but this time it's running on top of Kubernetes. If I do a Docker PS, it's the same. And since this integration is completely integrated in Kubernetes, I can also list stacks only with kubectl. So I have one stack with the name demo, and I can look at the YAML. So it's basically my compose file, but inside a Kubernetes object. So that I can use it even without the Docker CLI. So for instance, if I want to scale it, I can scale it by hand just with kubectl. Let's type patch. So I can patch the last service and let's say use 8 replicas. So my stack demo is patch, and when I look at the YAML, now it's 8 replicas. If I do a kubectl get all, everything is scaled, and if I refresh my application, everything is okay. So as you have seen, I can either use Kubernetes or Swarm to deploy my compose file, and if I use Kubernetes, I can either use Docker or kubectl CLI. So let's come back to the presentation.
And so that's pretty much it for the description of the kube integration. And what's next? Currently, we are integrating the 1.10 version of Kubernetes in Docker for Mac and Windows. So we should have this soon available in the coming releases. And on a bit longer run, we are working currently on integrating Kubernetes with Windows containers. So we're working with Microsoft on that, and we'll have updates on running a full kube cluster with Windows container as well as Linux containers.
Yes.
And yeah, so join us in DockerCon in San Francisco in June, and that's all for this presentation. So now it's open for questions.
Thank you.
Thank you, folks. So just a reminder for everybody who is attending our webinar, you can find the Q&A section in a Zoom interface in the bottom. So please ask your questions right there. So let's start with the existing questions. So when will Kubernetes enter Docker stable for Mac? It's probably when Docker for Mac and together with Kubernetes will enter the stable stage.
We're still checking when this will be possible in terms of also homogeneity with the EE version, and so we don't have any date yet to answer this question. We're looking at it. We know it's something that users want a lot, but we don't want to rush things, and we don't have a date yet available for that.
Right. Perfect. So we are ready for other questions. We also, there is the common question in the community. So is Docker for Mac with Kubernetes or Docker for Windows with Kubernetes is a replacement for Minikube? And how can you compare these tools with Docker for Mac and Docker for Windows?
So I don't think Docker for Mac and Docker for Windows should be a replacement for Minikube. So I think Docker for Mac and Windows comes for developers that just want to write things for Kubernetes rather than developers that want to develop things for Kubernetes. These tools are more intended to people that are developer in a company that use Kubernetes, not for Kubernetes developers. So in Minikube, you can configure pretty much everything. In Docker for Mac, it will not be possible for the moment, at least.
Yeah,
this is not the target.
And yeah, effectively, it's not the target. We're not trying to make everything configurable as it is in Minikube. We're trying to make things as as easy as possible to install and as easy as possible to get running quickly, so that developers can use Kube easily and don't spend too much time getting up to speed.
Yes. So some big difference with Minikube we have, it's with Docker you have the auto update, and you always have the latest version of Docker available. And with Minikube you have all the configuration possible, and you can pretty much set everything. On the common points, we both use kubeadm as a bootstrapper, so it's basically the same configuration, but with Minikube you can set pretty much everything you want.
Perfect. And what about the plans, the possible plans about Docker for Linux in the same way as you do with Docker for Mac and Docker for Windows? Well, everybody knows that Docker exists for Linux, like as a Docker daemon and Docker tool. But what about the complex solution where you'll be able to easily run Kubernetes with Docker tool on Linux and Linux desktop?
Well, currently we've got some experiments inside Docker to see what we could provide for Docker for Linux Kubernetes integration, but we don't have any specific date set for that, so I can't give you a date when this would be available. We are looking into this, and we know users are asking for a similar product on Linux to be able to very easily set up a Kubernetes cluster. We are trying to do some experiment to see what we could provide, but there is no specific date where we can say we promise we'll ship something.
Yes, for the moment you can do it pretty easily. If you are a Linux user, you just have to run Docker, install Docker, and do a kubeadm in it, and it will work pretty straightforward.
Yeah.
It's our current answer, I think. It's
yeah, so we have yet another question that is about, is there a way to get multiple Macs to join my Kubernetes cluster?
It's theoretically it could be possible. So
yeah, well, I think technically it's something that should be achievable. Not without too many difficulties, but since the target for Docker for Mac and Windows is really to have something running on your development machine and not to have a full production cluster with lots of nodes. We've just looked at it, but it's not really a very important target in our roadmap at the moment. We've done some experiments where we can run several virtual machines on your laptop and and have several nodes, one VM for each node running on your laptop. But the current target of Docker for Mac and Docker for Windows is really to have an easy setup of your development machine, and it doesn't seem to be a highly requested feature for developers. Okay. So it's something we could technically do. We might provide this in the future, but it's not really high up in the roadmap of the product.
Yes, and if you set up a cluster with Docker for Mac, at the end you will end up with a cluster of Kubernetes, but on Linux, not on Mac. So there is no point of having this. You can just have a regular Linux Kubernetes cluster, and it could be the same. Yeah.
Yeah, I think that's it.
Perfect. So since we don't have any other questions in the Q&A section, I'd like to thank you for joining us today and sharing your amazing experience with Docker for Mac and Docker for Windows together with Kubernetes. This webinar. Also, this is the call for all our attendees. Please join us at the next series of the webinars. Just note that this webinar is recorded and will be available on cncf.io website together with other webinars. So please watch this video later anytime if you want it. Thank you guys for joining us today, and hope to see you later.
Okay, thank you very much.
Thank you.